Hi everyone, welcome to Pre-Algebra lesson 10-2, Draw Geometric Figures. In this lesson, we'll be able to draw figures with given conditions. So let's start with the real-world problem, solve and discuss it. Students in the art club are designing a flag with the school's mascot and emblem. The flag has 4 sides with 2 sides that are twice as long as the other 2 sides. What shape could the flag be and what dimensions could it have? Make and label a scale drawing as part of your answer. So we have a flag with the school's mascot and emblem in there. Flag has 4 sides, so it's definitely 4-sided polygon, 4-sided shape with 2 sides that are twice as long as the other 2 sides. Okay, so maybe this would be X and that would be twice as long, and we have 2 sides that are twice as long as the other 2 sides. Or we could have this type of this type of 4-sided polygon where we have the longer lengths that are equal to each other exactly 2 times as the shorter ones, right? So it could be in the shape of a kite or it could be in the shape of a parallelogram, as long as they have 2 sides that are equal to each other and the other 2 sides that are twice as long. So dimensions, you could do any numbers for as an example. So let's see. I'm going to do both. You don't have to write both, but I'm going to say, okay, for my parallelogram, I could say, okay, if this was 2 centimeters, that the longer side would be twice as long, which is 4 centimeters. Okay, so what about the kite? Okay, if this side, the shorter side, is 3 inches, then the longer side would be twice as long, so 6 inches. Yeah. So, we made the scale drawing, we labeled everything, so that's it. Is there more than one shape that could represent the flag? Yes. It could be a kite, or a parallelogram. Okay, let's look at focus on math practices. How did you decide what lengths to use for the 4 sides of the flag you drew? What lengths could the actual flag be based on your drawing? So, how did you decide what lengths to use for the 4 sides of the flag you drew? Would you just find out the positive number, right? But then you need to start with the shorter ones first, right? You could possibly start with the longer side, but you just have to divide by 2 for the shorter side, and you might get a decimal. So in order to avoid decimal, we started with the shorter side and doubled it, right? Yeah. So that was our strategy. That was my strategy. What would be your strategy? So let's explain. For me, because 2 of the sides are twice as long as the other 2 sides, we first choose a length for the 2 shorter sides. Then we multiply that length by 2 to find the length of the longer side. So we had a 3-inch by 6-inch kite and 2 centimeter by 2 by by 4 centimeter parallel. Let me go to the next parallelogram. There we go. Okay, so that was an example of how we could use geometric figures in real life and the scale drawings and the units. So let's go to example 1. Draw a quadrilateral with given conditions. The school's landscaping club is designing a 4-sided patio and garden. The patio has 2 perpendicular sides that each measure 4 yards, and a third side that is perpendicular to one of the equal sides, but twice as long. One angle of the patio measures 135. Make a scale drawing of the patio using a scale of 1 centimeter equals 1 yard. So if they didn't draw this for you, would you be able to understand and draw a scale drawing by yourself? If not, listen to these steps carefully. So first of all, we have a 4-sided patio and garden. So we know total it needs to be a 4-side. Patio has 2 perpendicular sides. Perpendicular meaning 90 degrees, right? So 2 perpendicular sides, 90 degrees. That is perpendicular to one of the equal sides, but twice as long. So, that each 2 perpendicular sides that each measure 4 yards. So, 2 perpendicular sides that each measure 4 yards. So we can have 4 yards here. Wait, 4 yards. Okay, so we're going to draw a scale that is equal to 1 centimeter per yard, right? So we could say this is 4 centimeter. Then we have another side that is 4 centimeter. But then the other side, the third side that is perpendicular to one of the equal sides would be one of the equal sides, but twice as long. So twice as long, 4 times 2, right? And then we have the other side like that, okay? So then we have 4 by 8, and we don't know what this would be, but this is also 4 centimeters. So the shape would be a trapezoid. This is called the trapezoid if we have 2 parallel sides and then non-parallel for the other ones. That is, if we only have 1 parallel sides, 1 pair of parallel sides, then it would be a parallel. It would be a trapezoid. Okay, so try it. Use a ruler and protractor to draw a quadrilateral with 2 equal sides that meet at the right angle and 2 non-adjacent, so they're not like right next to each other, angles of the same measure. What is the name of the quadrilateral you drew? So try to draw this quadrilateral and see if you can figure it out by yourself. Pause the video, come back when you're ready for answers. Okay, are you ready? So, where do we start from? Quadrilateral with 2 equal sides that meet at a right angle. So they meet with a right angle, okay? And then they are equal sides. And then 2 non-adjacent angles of the same measure. So non-adjacent means 2 angles that are not right next to each other, which means this angle must be the same with not these 2, but the opposite angle. So the opposite angles are the same. So if the angles of these 2 are going to be the same, the sides here have to be the same also, right? So this is going to be a kite. Okay, so could you have drawn more than one shape that fits the given conditions for this one? Could you think of another shape that fits this? Yes, you could maybe draw another another shape, but it's the type of shape is still going to be a kite, right? So these two sides would have been longer. It could have been longer, right? Like that, right? Yeah. So the right angled sides could have been longer than the other side. So let's see. Yeah, so we have a right angle here, and then we have this type of angle where it's like really small, right? Where this angle is greater than 90 degrees. So this side is shorter, and then this side is longer. Or you could draw another quadrilateral like that, which looks like a boomerang. So yeah, you could have drawn more than one shape. Yes. We can draw other shapes like these. Okay. So let's move on to example 2. Draw a figure to solve a problem. Mr. Miller's classroom has desks shaped like equilateral triangles, like that. He is planning to arrange desks for lunch for 10 people. If one person can sit at each edge of each desk, make a sketch to show how many desks he needs. So equilateral triangle means that they have all three equal sides, right? So one way he could arrange the desks like this, looking downwards and then looking upwards, looking the other way, and then like that, like crisscross, right? Another way, we could make shapes like these where, yeah, we could have tables over here, or we could put, yeah. So these tables, nobody's gonna sit here, but in order to make a safe shape, it is necessary to put these tables in there, but yeah, we have less people that could sit around, right? So yeah, there are different ways to arrange these tables. So in this case, he will need 8 desks to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. In this case, he'll need 14 desks to make this arrangement. Unless you put this table away, but then our shape is going to be a little bit weird because the people in the middle will probably move their desks like over here and here, and then the shape would be destroyed. So yeah, we do need 14 desks. Let's look at example 3. Draw a figure using technology. An engineer makes a scale drawing of the floor of a building. The floor has 2 pairs of parallel sides that are 50 feet and 80 feet. 2 of the 4 angles measure 60 degrees. Use geometry software to make scale drawing. What is the name of the floor shape? So in online, we have geometric technology, geometry software like this, where you could draw geometric shapes and lines and points, right? So you can draw 2 line segments at 60 degrees angle. So maybe you could go to GeoGebra if you're looking for a website to use this. So draw 2 line segments at a 60 degrees angle. Yeah, 2 of the 4 angles measure 60. So yeah, we could say, oh, this is 60. And then sides that are 50 and 80 feet. So this would be 50 feet, and then that could be 80 feet. We don't need to do 50 units if we could just represent it with 5 units and 8 units. As long as they're proportional, it's okay. And then this angle does not have to be 60, but you have to have the same angle on the opposite side if it's going to be 4 sides. So 60 degrees, 60 degrees, and this does not have to be exactly what, right? So it could be a little bit tilted like that too, as long as this is 60. Oh wait, that did not look like 60. Yeah, so this could be a little bit shorter like that, right? So it could be a little bit shorter as long as these angles are 60, and then one is 5 units and the other one is 8 units. Okay? Yeah. So make a sketch to show another way Mr. Miller can arrange this to see 10 people for lunch from example 2. Use geometry software to make a rhombus with a side length of 6 units and 2 angles that measure 45 degrees. So this is the first one. This is the second one. Wait, this is from example 2. This is from example 3. So pause the video, see if you can just draw. You don't have to use the software, but if you could draw it here, that would be great. Pause the video, come back when you're ready for answers. Okay, are you ready? So if you look at the first one, make a sketch to show another way. Did you figure out another way? So think about your classroom. Does it always have to be all connected? No, you could also separate them too. Like, it's okay. So maybe we could have this triangle, and that triangle together like that. 1, 2, 3. And then we can have another group like here, this triangle and this triangle and this triangle. Whoops. This triangle and this triangle. So people can sit here. So, but then that is 1, 2, 3, 4, 5, 6. And then we can have another group of table here. 1, 2, 3. Then we could have another group of table here. 1, 2, 3. I don't know how big the classroom is, but we can have some space in between these groups. And then we have, that is way too many people, right? So then we need just one more person. Maybe we could just have a desk of 4, a group of 4, and a group of 2 groups of 3. We don't always have to have the same number of groups, right? So yeah, so this is another example. If you prefer to come up with other great examples, yeah, we could all share ideas. What about this type of arrangement? We could, with this group, we could have people sit over here on this side and this side, and then on this side and on this side and this side, and that would be 5 people, right? Now we could only use 6 tables and of course 10 chairs, but we could just save space like that. So if Mr. Miller's classroom is super small, we could probably use this idea to maybe cluster people together. Or if we want groups that are more spread out, we could use this idea. So yeah, there are many other ways to do this. Okay, so example 3, try number 3. Use geometric software to make a rhombus with a side length of 6 units and 2 angles that measure 45 degrees. So rhombus means you need to have 4 equal sides, right? So then it could be like that, as long as they're equal. And then each sides would be 6 units. And then 2 angles that have to be 45 degrees. Yeah, as long as 2 angles are 45 degrees and all sides are equal to each other, that would be a good rhombus. Okay, so that was lesson 10-2, drawing geometric figures. This is the key concept. You can draw shapes that meet given conditions freehand with a ruler and protractor or with technology. So the given conditions may include properties of geometric figures and relationship between parts of the figures. We'll probably talk about sides and angles and how many sides do we have. And so in this lesson, we mostly looked at 4-sided quadrilaterals, but we also talked about triangles, right? So there could be different sides too, number of sides. And then the length of each size. Yeah. All right, so that was it. We'll continue with the next lesson in the next video. Thanks for watching, guys. Bye.